All right, guys, if you want to make this study guide with me, there are 2 Google Slides documents attached to this. And if you print them front to back and then place them in this order, so we want multiplying polynomials, adding and subtracting right underneath it, and then naming polynomials under that. Like if you stack them like that and then just fold it in half, then we end up making this kind of cute little book where if we open up one page at a time, we get naming polynomials and then a practice problem underneath, and then adding and subtracting polynomials and some practice problems underneath. I want to zoom this out just a smidge. And then multiplying polynomials, and again, examples underneath. And so we have a little booklet like that. And then the other one, the other Google Slides page, when you print that one out, again, front to back, if we place them one on top of the other, where we have this one with like the x squared 2x y squared, and then right underneath that, we want factoring ax squared plus bx plus c, and then underneath that, factoring x squared plus bx plus c. And again, just like the other one, if we fold this in half down to make a book, you'll have the title on the top and then a cute little practice problem underneath. So again, I'm going to fill each of these out and talk you through all the material that we went through in this chapter. If you want to fill them out with me, you can. But if you just want to watch the video for a quick little review, that's great too. So I'm going to start with the factoring one, that second one that I was showing you. So this is my little factoring booklet, all the factoring fun. And if you remember going back, the first thing that we factored was actually a GCF. But after that, we factored a trinomial without a number up front. And this one was where we just made our X puzzle. So, for example, if I have a trinomial like x squared plus 8x plus 15, we make our X puzzle where we put 15 at the top, 8 at the bottom, and we think about what multiplies to 15, so like 1 and 15, 3 and 5, and of those pairs, which ones will add to 8. So because 3 and 5 multiply to 15 and add to 8, when I write it out in factored form, we'll have x plus 3 and x plus 5. Now another quick example like that one, again, if I have a trinomial that does not have a GCF, we make our little X puzzle where we put the last number on top, so 14, and our middle number on the bottom, so negative 15. And we think about all the factors that multiply to 14, so 1 and 14, 2 and 7. And of those, we want to pick the ones that will add up to negative 15. And so if I make the 14 and the 1 both negative, it will still multiply to a positive and will add to a negative. And so we write out our answer, x minus 1, x minus 14. Now, the next day, we ramped it up a little bit and we said, okay, well, what happens now if there's an a value out front? And so with that one, we kind of did it the same way. We still had to make our X puzzle. I just had to slide the a over, then divide the a out, and then bottoms up. So slide, divide, bottoms up on this one. So for example, if I have 2x squared plus 3x minus 14, I need to take that 2 and slide it over, which means I multiply it for negative 28, and then I'm still thinking what multiplies to 3. So the things that multiply to 28 are 1 and 28, 2 and 14, 4 and 7. And then of those pairs, the ones that will get me a positive 3 is if I make the 4 negative and then keep the 7 positive. And they'll also multiply to the negative 28 that I need. So we actually write it out the same way as the last one. So we put that x minus 4, x plus 7. But because I slid that 2 over, I got to divide that 2 out. Like, it's kind of illegal for me to multiply that 2. So now I got to undo that I did that. So I divide each thing by 2. And if I can divide, I will. So like 4 divided by 2 is 2. But if not, bottoms up. And so we get 2x plus 7. And so our fully factored form is x minus 2, 2x plus 7. Now, after we did that extra credit along with it. But then Monday, just in case you're watching this later, we talked about two special cases. Now, these only work when I have perfect square numbers, like square rooty numbers. And we kind of had two patterns with that. If I had some square rooty numbers on a trinomial, then whenever I got my answer, it was always parentheses squared. But I had to follow the pattern. Like I had to be able to square root the first one, square root the last one. So for example, if I have x squared plus 6x plus 9, I can take the square root of x squared, it's x. And I can take the square root of 9, it's 3. Then I had to double check the middle number. So with the middle number, I need to multiply these two numbers. So x and 3 is 3x. And then double it for 6. And so since it checks out, we can rewrite it as x plus 3 squared. Another example like that would be something like 9x squared minus 12x plus 4. So because I have a trinomial and I can square root the first one for 3x and I can square root the last one for 2. And when I multiply these and double it, I get the 12. I can do the little shortcut. I just have to keep in mind that because the middle number is negative now, it's not going to be x plus 3, it's going to be minus. So 3x minus 2. Now the other little pattern that I showed you on Monday was similar, where I had the perfect squares, like the square rooty numbers. However, it wasn't a trinomial, it was a binomial. So again, if I have those square rooty numbers in a binomial, we got like the same parenthesis, but one was a plus and one was a minus. So I couldn't do the little shortcut where you square it because they do have different signs in it. So for example, if I have 64 minus m squared, because it's a binomial being subtracted, and I can square root these numbers, so square root of 64 is 8, and square root of m squared is m. I can write it out in factored form fast, 8 plus m and 8 minus m. And one more example like that, if I have 36y squared minus 9x squared, it has to be a minus. If these are both square rooty numbers, so square root of 36y squared is 6y, and the square root of 9y or x squared is 3x, then I can do it. And I don't need to check a middle number on this one, so we just write the same parenthesis twice, except for one with a plus and one with a minus. Now, really reaching our brain back, like I said initially, the first type of factoring we did talk about was factor by grouping. And this is where we look for a GCF. However, when I have 4 numbers, it's super tricky to get all 4 numbers to have something in common. So we kind of did a little bit of a cheaty move. So if I had a 4-term polynomial like 12x squared minus 15x minus 16x, I'm so sorry about that, plus 20, all 4 of these don't have something in common. It's like I really wanted to pick 4, but 5 doesn't work. And even if I wanted to pick 2, the 15 doesn't work. So what we get to do is just look at 2 at a time. And so if I look at the first 2, I notice that they have a 3x in common. And then 3 times 4 gets me the 12 back, and I leave 1x behind. And 3 times negative 5 gets me that negative 15 back. Now in the next one, I noticed that they had a 4 in common. And originally I thought, okay, 4 times negative 4x will get me the negative 16 back, but I needed to have twins here. So I actually took the minus sign out, because then negative 4 times 4 will get me the negative 16. And inside here I have a positive 4 like I have over there. And negative 4 times negative 5 will get me the positive 20. And then I end up with twins. This was the one where you wanted to get twins. And so you write your twin down, and then you write your GCFs down. So 3x and minus 4. Now that's all the stuff that we've been talking about lately, but before our quiz, we also had the exact opposite of all this stuff. factoring is sort of like dividing, but I don't lose any information. If we grab our other set now, if we remember before that, we were talking about polynomials and how I name them, how I add and subtract them, and how I multiply them. And again, the multiplying was kind of the biggest deal, where we were doing the box. And then factoring is the exact opposite of that. That can sometimes be tricky here. So if we open this one up, the first thing, like I said, we talked about was naming polynomials. And there were really 4 things that we talked about: being in standard form, the type of the polynomial, the degree, and then the leading coefficient. So to be in standard form, I need to rewrite my polynomial in order from biggest exponent to smallest exponent. So like here, it wasn't in order because like x to the 8th was the biggest. So I really needed to rewrite it with that one at the front. And then I didn't see a 7 or a 6 or a 5 or even a 4. But then the next one we had was a to the 3rd power. So that goes next. And then a to the 2nd power. Then to the 1st power, and then no power. Now, when anything has more terms than 3, it's just a plain old polynomial. The degree is really just another word for exponent. So the biggest one was 8 because our degree is always the biggest. So biggest exponent. And then LC stands for leading coefficient, which is just the number on the biggest, or the number at the front. Now looking at the second example here, this one was already in standard form. So I just rewrote it. And I rewrote it as a 5 because it gonna go cut off when I printed it. Now this one, because there's 1, 2, 3 terms, is a trinomial. The degree is the biggest exponent, so in this case it's 2. And then the leading coefficient is the front number, so 5. This one I did have to rewrite to put 6x first and then take the minus 7 with it to be in standard form. Because there's only 2 terms, that is a binomial. My degree is the biggest exponent, and there is a hidden 1 there. So 1. And then the leading coefficient is 6. Now for the last one here, because it's just a 5, like that's kind of already in standard form. And because there's only 1, it's a monomial. Now because there's no variable, there is no degree, so 0. And that kind of means your leading coefficient just has to be 5. Like that's the only number there is. Now along with that, we also talked about adding and subtracting polynomials, which really when we're adding and subtracting polynomials, we're kind of just looking for like terms. Now like terms means that I have the same letter and the same exponent. So if I have that, then I just end up adding or subtracting the numbers in front. So with this one here, I went through and I looked for the biggest exponent because I wanted to put it in standard form. So 4n to the 3rd was the biggest, and there were no other n to the 3rds, so I just brought it down. After 3, I want to look for 2's, and there was only this negative 2n to the 2nd, no other ones, so I just brought it down. Then I'm looking for n to the 1st, which is just n, and over here I had 2 of those. So like there's a negative 3n and a positive 7n for a total of 4n, because like negative 3, positive 7 is 4. And then I just brought the 12 down because he didn't have any buddies to combine up with. This would be a polynomial of degree 3 with a leading coefficient of 4. Now, we also talked about subtracting. However, if you remember, Missouri hates to subtract. It's no fun. I just like to distribute my negative, aka change all the signs, and then just add like I did in the last one. So this first one, I just brought the polynomial down, or the trinomial down. Here I had to change all the signs so that I was distributing the negative through. So like negative x to the 3rd, positive 2x, and then minus 3. And then just like the last one, I was looking for my like terms. So same letter, same exponent. And the biggest one was the x to the thirds. And there were 4 here and negative 1 there for a total of 3. I didn't see any x2s. And so then I jumped to the x to the first. And there were negative 2 here and positive 2 there for 0. So I didn't write any x's down because negative 2 and positive 2 is 0. And then I added the non-x's, like the plain old normal numbers. So 1 and negative 3 for negative 2. This would be a binomial with degree 3 and a leading coefficient of 3. Now, after we talked about adding and subtracting, we talked about multiplying. And we actually started pretty easy where we were doing just a monomial, one number, times a binomial. And really, this is low-key just distributing. We just have to be a little bit careful with our distributing here because I need to multiply the big numbers, like the front numbers, and I need to add to the exponents, so the little baby numbers. So when I distribute the 4x squared here, there's like a low-key 1, and 4 times 1 is just 4. So I multiplied the big numbers, but now when I'm multiplying the x's, I need to add the little numbers. So that's why it ended up being x to the 5th. And then there's a y there too. Then when I distributed it here, we did the 4 times negative 12 for negative 48. And there's an x squared attached to that as well and no other letters, so it doesn't change at all. Now, we ramped it up a little bit pretty quickly after that where we started multiplying monomials times, oh, I thought I had another one in here. This is still just distributing. A monomial times a trinomial, that's still just distributing. We're doing one number times 3 numbers this time. But we're still just distributing. We're going to multiply the big numbers and add the baby numbers, add the little exponents. So when I distributed it here, we just have to distribute 3 times now because we're going to 3 numbers. So negative 4 times negative 9, positive 36. And then when I multiply my x's, I add the exponents. So there's 1 here, 2 there for 3. Then when I multiply big numbers here, we're going to get negative 20. And then an x and an x is x squared. Lastly, when I distribute it to the negative 8, negative 4, oh, positive 8 rather, negative 4 times positive 8 is negative 32. And there's an x there as well. And it doesn't get any bigger because that doesn't have any more to add to it. Now we go ramp it up. So after that, if you guys remember, we made this crazy multiplying madness book where I talked about multiplying binomials by binomials, binomials by trinomials, trinomials by trinomials. It was crazy. We're just going to do binomials times binomials. Nobody wants to do a 9-box thing, a 3x3 square. No, thank you. And guys, when we were doing this, I showed you 4 different ways that we could multiply. I initially showed you the box where we made like a 2x2 square or a 2x3 or a 3x3, whatever you're multiplying. Then I showed you distributing twice, or like we've talked about in some of my hours, doing the over, over, under, under. So like over, over, and under, under, distributing twice. I then told you that people took that and made a little acronym out of it for FOIL, which that stands for first, outer, inner, and last, as a cute little acronym to help me remember which numbers I multiply. Or we also talked about stacking them, like old school multiply where I just stack the numbers on top of each other and I multiply away like I would normally do, which I think was everybody's least favorite. And as I'm going through and doing these, we multiply all the numbers first, and then I think about maybe adding up like terms. So it's really a combination of 2 things here. Multiply, then add. So for instance, if I'm taking x plus 4 times 5x minus 3, I can make a 2x2 square, and we multiply to get each box. So when I multiply here, we get 5x squared because 5 times 1 is 5, and x times x is x squared. When I multiply here, 5 times 4 is 20, there's also an x. When I multiply here, I get negative 3x. And when I multiply at the end, I get negative 12. Always along our diagonals, we end up with like terms. The other two boxes should not be like terms. And so when I end up doing this, the 5x squared stays the same, but the 20x and the negative 3x becomes 17. There's 20 minus 3x. And then I have a minus 12. Now we did talk about some special cases, but I can always just do the box. So like 2x minus 3 squared means I'm doing 2x minus 3's. So I have a 2x minus 3 on the top and a 2x minus 3 on the side. We multiply to get each box. So 2 times 2 is 4. X times x is x squared. Then when I multiply here, I get negative 6x. When I multiply here, I get negative 6x. And when I multiply here, I get a positive 9. So again, along my diagonals, I should get some like terms. The 4x squared stays the same. Negative 6 and negative 6 is negative 12x. And then we have a plus 9 at the end. Now guys, your test will be over all these things. So hopefully this helped to remind you of this entire polynomial fun. Good luck. I'll see you next time.